So I'm going to switch gears again. And when I listened to the next presenter previously, I texted my husband that I needed his 3D printer at home. So our next speaker is Jeffrey Collins from the College of Architecture and Construction Management. His talk is about layer by layer, rethinking architecture through 3D printing.
So here's a question. How many of you live in a 3D printed home? It might sound futuristic, but it may also be closer than you think. With fabrication technologies evolving, this vision is becoming a reality and will shape the future of architecture. So why ditch the old way of building? The answer is traditional construction is too wasteful of both time and material. But 3D printing, building layer by layer, uses only what's needed. This precision can cut waste, speed up building time, and drive a sustainable future. But it's not just about efficiency. What I'm talking about is a whole new design process. With direct-to-fabrication, architects can move more smoothly between digital tools and physical models, enabling faster prototypes, incorporating material insights, and creating designs that are more responsive and adaptive. And of course, that I teach, 3D printing gives students this learning experience. They design digitally and then engage with their creations physically, diving deeper into spatial design, material behavior, and production constraints. And then they repeat. This iterative loop lets us challenge conventional ideas and uncover fresh architectural possibilities. Students see the combination of digital precision and hands-on experimentation allows us to create forms that traditional methods can't achieve. Often our designs start with a single component. The magic happens when we assemble these together into complex modular structures. This approach shows how even the smallest parts, thoughtfully combined, can lead to entirely new architectural forms and functions. So far, we've worked with models and small-scale prototypes, but our vision extends to full-scale construction. Transitioning from models to full-size components will help us understand how 3D printing can meet the functional and structural needs on a larger scale. One tool we're using for this is the clay extruder. By translating digital designs into clay forms, we connect with a sustainable and historically familiar material. After all, clay has been used in pottery for centuries. But could it go further in architecture? Could 3D printed clay components go beyond decorative pieces to become functional structural elements? These questions to drive our experimentation and the types of forms we're trying to print. Our initial experiments started with just controlling the extrusion process, how things like clay consistency, pressure, speed, nozzle diameter all combine to have an effect on the form. Each test provided essential insights into what's achievable and where we need improvement. Of course, we learned from our failures too. Each collapsed structure, air bubble, wonky layer helped us refine our techniques, sharpening both our designs and our understanding of the clay printing process. Alongside these physical trials, we continued digitally strategizing how each part could connect into a larger structure. Again, this iterative approach revealed not clay's limitations, but its promising potential. Our experiments can expand beyond just exploring form to addressing architectural challenges like filtering light, air, and water. We will adapt our printed components to respond to these functions, weaving both utility and beauty into the designs. So I want to tell you a little bit about the extrusion process. It requires a meticulous setup. Getting the clay consistency just right, loading materials correctly, slicing the digital models into layers are all crucial for successful prints. After extrusion, each piece dries, gets any touch-ups we think are needed, and then is fired. Our clay printer is on the Marietta campus. We don't have a kiln. So we've partnered with the Department of Ceramics and the Kennesaw campus for firing. Transportation involves careful logistics to ensure each piece survives the trip. We've only had a few casualties. After the first firing, we glaze and fire again for durability and aesthetic quality, assuring each component meets standards for structural testing and installation. Once the pieces are complete, we finally get to the assembly stage, the true test of our design's structural and visual impact. Now at full scale, rather than just models, it transforms theoretical ideas into tangible, functional forms. Looking ahead, we're focused on refining this process even further, enhancing connections, improving performance, and adapting processes for large-scale production. Again, our ultimate goal is to make 3D printing scalable and accessible for real-world applications. As we expand, we're also exploring materials beyond clay, such as waste products. These eco-friendly alternatives could bring even greater sustainability to construction and open even more doors to what 3D printing can offer. So, perhaps one day soon, many of us will live in a 3D printed home. As digital design, sustainable materials, and 3D printing intersect, the future of architecture is being reimagined layer by layer. Thank you.